In this presentation, we'll be discussing meter. In the millennia that humanity has explored music making, musical time has been organized in a variety of ways. For instance, many cultures have genres of music with free, almost improvisatory approaches to time. These free approaches to time are often contrasted with more ordered temporal systems. In the common practice era, and the musics which look to this style as being important, music is frequently organized into recurring impulses of strong and weak beats called meter. Now, for this presentation, I'm going to assume that we understand the basic additive properties and relative values of rhythmic notes. For instance, 2/8 equal a quarter, 3/4 equal a dotted quarter, etc. If you're less familiar with those, maybe practice those and come back to this. So, meter is the organization of strong and weak impulses into recurring patterns. I say impulses here, that's basically another word for beats, for sonic formations that give us a sense of time. These impulses are assumed to occur at regular intervals. The music's tempo governs how frequently these impulses occur, using beats per minute as their measurement. We perceive meter aurally. Even music without a written metric designation can create the effect of meter based on its pattern of strong and weak impulses, often aided by patterns of dissonance and resolution. For instance, in Renaissance polyphony, we actually don't have meter, but we have the aural effect, we don't have a written out meter, but we have the aural effect of meter that's created by the interaction of pitches and rhythms, and particularly the resolution of dissonances into consonances. Now let's talk about a few types of meter. There are many types of meters, but for now we're going to be looking at what are called symmetrical meters. Those which create the same number of strong and weak impulses when grouped together over many groups, or essentially many measures. These meters are typically categorized based on two aspects: how many impulses or beats are in a grouping, and for now we'll be talking about ones with 1, 2, 3, or 4 beats per grouping, and how many basic units of subdivision within a beat, and for now we're going to be talking about subdivisions of 2 and 3. So let's talk about these beats per grouping, or essentially how many beats per measure. Meters in the common practice era tend to have the following number of beats per grouping, with certain beats being stronger than others. Note that some dance forms like the mazurka will have different relative strengths and weaknesses within the meter. If you listen to Chopin's mazurkas, you'll often find that it's beats 2 and or 3 that get the emphasis rather than beat 1. But in general, if we're talking about a broad categorization of how meters sound and work, this is typically what we'll find. So we might have a single meter with just 1 beat per grouping. That's relatively rare, but it does occur. We can have duple meters, where the strong beat comes on week 1 and a weak beat on beat 2. We can have triple meter, that's 3 beats per measure or per grouping. The strong beat is beat 1, the weak beats are 2 and 3. And we have quadruple meter, with strong beats on 1 and 3 and weak beats on 2 and 4. So that's the first thing to consider, is how many beats per grouping or beats per measure. That's going to be the first thing, one of the first things that we're looking at when we're talking about meter. Another aspect to consider is the number of subdivisions in the grouping. In the common practice era, meters are also categorized into whether the first subdivision of the beat note is in 2 or 3. Of course, these can be subdivided further, but I'm talking about the first order subdivision. So a first order subdivision, for instance, of a quarter note would be an eighth note. The first order subdivision of a dotted half note would be quarter notes. So if the beat note is subdivided into 2, then the meter is known as simple. If the beat note is subdivided into 3, then the meter is known as compound. Therefore, a meter which has 4 beats per grouping, and these beats are each subdivided into 3, the meter would be known as a compound quadruple meter. So it's quadruple because there are 4 beats per measure, And if it's subdivided into 3, then it's compound. So we have 1 and a 2 and a 3 and a 4 and a. That would be our compound quadruple feel. Now, during the last millennia of European music, a variety of approaches have been utilized to denote the organization of rhythm. The approach that became utilized during the Common Practice era was known as a time signature. And I should note that it is not a perfect method for noting meter. In fact, any of the notation systems that are out there will have strong aspects to it and weak aspects to it. Other approaches, including rhythmic modes, which was used in the medieval Notre Dame school, and mensuration signs. These were both used during the Middle Ages, while Renaissance polyphony, as I mentioned, used no metric signs at all. So the time signature is not the only way. It's just the way that's frequently used now in Common Practice era style performance and education. And as I say, there are some things it's very good at and some things it's not so good at. The time signature itself is based on a straightforward formula which is made less straightforward when applied to compound meter. So we'll talk about that more in a second. Time signatures consist of 2 numbers, one on top of the other, making them look like a fraction. The bottom number denotes a note value, and in the Common Practice era will always be even. Common values that we'll see include a 1, which denotes a whole note, 2, which means a half note, 4, the one you're probably most familiar with, which means a quarter note, 8, which means an eighth note, and 16, which means a 16th note, and it can go on and on from there. The top number denotes how many notes of that value are in each measure. So if you were in a 1-1 measure, each measure, or 1-1 meter, you would have, each measure would have a whole note in it. If you were in a 32-16 time signature, each measure would have 32 16th notes in it. Let's talk about how time signatures are used with simple meters. Simple meters, those whose beat notes divide into 2 subdivisions, are translated into time signatures in a relatively straightforward manner. Simple meters will have a top number, first of all, that is even and not a multiple of 3. For instance, 2-4, 4-4, and 4-2 are all simple meters. The top number is all even and not divisible by 3. Meanwhile, 6-8, 9-4, and 12-16 are not simple meters. Their top number is divisible by 3, even though 2 of those are even on top. The one exception is 3-4, 3-4 most of the time, as well as some other meters like 3-4, 3-2, 3-8. If there is a 3 on top, that is oftentimes a simple meter. In simple meters, the bottom number is in a simple meter is the beat note. So that is the note that actually gets the beat. And that's in some ways why they're simple. They're relatively straightforward that way. The top number is how many beats per measure, and the bottom is the beat note itself. So for simple meters, one simply looks at the top number to determine whether the meter is duple, 2 beats per measure, triple, 3 beats per measure, or quadruple, 4 beats per measure. Some simple meters have common abbreviations because they're used so frequently. 4-4, for instance, is usually referred to as common time and often abbreviated with a C. 2-2 is frequently referred to as cut time and will sometimes be abbreviated with a C with a slash through it. Now, let's get slightly more complicated. Let's talk about compound meters. Translating compound meters into a time signature was slightly more complicated in the Common Practice era. You may recognize a compound meter time signature because the top number will be a multiple of 3, but typically not 3 itself. So 9-8, 6-4, and 12-16 are all compound because their top number is divisible by 3. The bottom number of a compound time signature represents not the beat note, but the first order subdivision of that beat note. So that makes it more complicated than the simple meter. Therefore, to glean what meter a compound time signature represents, we have to do some reverse engineering. First, to know whether the meter is duple, triple, quadruple, etc., we're going to divide the top number by 3, and the result will tell us what feel it is. So 9/8 divided by 3 would result in a triple meter. So 9 divided by 3 is 3. 6 divided by 3 is 2. That results in a duple meter. Second, we have to identify the beat note. So we observe the bottom number, that's the subdivided note, and add 3 of those notes together, essentially multiply it by 3. So if we had 12/16, we'd have to multiply that 16th note by 3. 3 16th notes together equals a dotted eighth. So the dotted eighth would be the beat note. Let's walk through an entire example. Let's start with 9/8. So we're going to divide the top number by 3, resulting in 3 itself. So the meter is compound triple. It is triple time because there are 3 beats per measure, 9 divided by 3. To find the beat note, we observe the bottom number, the 8th note, and we'll add 3 of those together to get a dotted quarter. The time signature of 9/8 therefore denotes a compound triple time with 3 dotted quarter notes per measure. And we can check our work by comparing and counting the number of 8th notes in the measure. 3 dotted quarters equals 9/8 notes, which is the same number of 8th notes indicated by the time signature itself. 9 notes, 9 8th notes, as we saw. Let's practice with some actual music now. Here is a piece by Joseph Boulogne, Chevalier de Saint-Georges. This is his string quartet in C minor, and we see that it is in 4/4 time. Now, you're probably very familiar with that, but we'll walk through it very briefly. We look at the bottom number. We know that, well, first of all, we look at the top number, and we see that it is even, and it is not divisible by 3, so it must be a simple meter. So there are 4 beats per measure, and what gets the beat? Well, we look at the bottom, and that is a 4, so that means a quarter note. There are 4 quarter notes per measure, or 4, and with the quarter note getting the beat itself. Because we know that it's simple, and there's 4 beats per measure, it's going to be simple quadruple, with the quarter note getting the beat. Let's go on now to this art song by Fanny Mendelssohn Hensel. This is Ferne. And we are in 3/4 here. Now we already recall that with 4 on the bottom, that means the quarter note gets the beat. Because it's 3/4, we remember that 3 was the exception, and so that is going to be a simple meter. And since it is, we have 3 on the top, it's going to be simple triple. So that 3/4 is simple triple, with the quarter note getting the beat and 3 quarter notes per measure. Then down at the bottom, we have Germaine Taillefer. We have her Berceuse for violin and piano. And we have here a 6/8 time signature. So first, we are probably alerted to the fact that this is a compound meter because 6 is divisible by 3. So 6, we're going to now work through how many beats per measure, and we're going to work through what gets the beat. So to figure out how many beats per measure, we look at the top number and divide it by 3. 6 divided by 3 is 2, so we know it is a duple meter. There are 2 beats per measure, with each of those beats being divided into 3. Now let's take a look at the bottom number. Remember that bottom number in compound time is not the beat note, but the subdivision of the beat note. So to find that beat note itself, we're going to take an 8th note and multiply it by 3. 8th plus 8th plus 8th equals a dotted quarter. So this is a meter that has 2 beats per measure, with each beat being a dotted quarter, and those dotted quarters being subdivided into 8th notes. 1, 2, 3, 2, 2, 3, 1, 2, 3, 2, 2, 3. So this is a compound duple meter, with the dotted quarter note getting the beat, and 2 of those dotted quarter notes per measure. To review, meter is the organization of strong and weak impulses into recurring patterns. And in the common practice era, meters were typically organized by means of how many beats occur per measure, for instance, duple, triple, or quadruple, and whether these beats were subdivided into 2 for simple meters or 3 for compound meters. These meters were denoted by time signatures, which consisted of two numbers. For simple meters, the top number indicates the number of beats per measure, and the bottom number indicates what note gets the beat. For compound meters, the top number divided by 3 equals the number of beats per measure, and the bottom number multiplied by 3 equals the beat note itself.